Welcome back to the channel. One of the most common questions that I see guys ask about Foxbody Mustangs and other 5-liter Fords for that matter is, how do I get my car to idle right? It's a common theme on pretty well every Foxbody group that I'm on, and there are lots of guys giving advice on this. There's lots of YouTube videos and there's lots of mouthpieces on these forums explaining how to do it. But the truth is, most of this advice is only partly correct, or it's incorrect. It gives credit to the Foxbody's engine management system for doing things that it just doesn't do, and it typically results in frustration when it comes to trying to get the car to work. What I'm going to do today is go through the initial setup steps you should take on your car, how the idle control actually works. I'm going to give you a little bit of a look inside the software at how it's programmed, and we're going to discuss the steps that you can take to try and get your car to idle right, or at least reasonably. Now, your results are going to vary depending on how heavily modified your car is. The example car here is the project we call Bad Decision. Right now, this car is a stalker. The engine in this car is so stock that I had to tear the tape on the spout connector in order to set the timing. It has stock injectors, it has a stock throttle, and it has a stock mass air meter. It is an 88 car, so it's the subject of a conversion. It has an A9L computer in it, which is what probably most of you guys are going to be running. And the math, although obviously not correct for an 88, is taken from a stock mass air Mustang. The first thing that you should be doing with a physical setup on one of these cars is setting the timing. So the correct factory timing setup is 10 degrees before top dead center with the spout connector removed. You connect your timing light to the number 1 spark plug wire, which you can trace down to the number 1 cylinder, which is the most forward one on the passenger side of the car. On the Ford, they're numbered 1 through 4 on that side and 5 through 8 on this side, in case you came from the GM world where they're odds and evens. You remove the spout connector, which is this little connector here on the TFI distributor. That disables computer control of the timing, and you loosen the distributor hold down, and then you adjust it using a timing light until you get to 10 degrees before top dead center. Now, it's true that if you have a stalker, and especially if you're going to run premium fuel, you can bump that timing up to 12 or 14 degrees before top dead center and get a little power bump from it. If you're using chip programming, especially something that I would supply, then you should set it at 10, because I will have added the additional timing in the programming, in the software, and that always works better than bumping the distributor. If you've got a car that just doesn't want to idle, start from first principles, set it stock, set it to 10 degrees before top dead center. Once you have the timing set correctly, you can move on to setting up the idle and try to get the car to idle smoothly. Let's talk about the idle control on the car. How does it actually work? Well, the Foxbody has a very simplistic idle control. It consists of a single actuator, which is an idle air bypass valve. That's this big valve here. What that valve does is allows air to bypass the throttle blade. And the amount of air that allows to bypass the throttle blade is controlled by the position of that valve, which is managed by the computer. That's it. That is the only computer control for idle on the car. There's no other voodoo stuff, and anybody who's telling you that there is wrong. The idle air bypass valve is the only control over the idle. But there are a couple of other things that can impact your idle. Number one is the throttle stop. Regardless of which throttle you have, on the underside of the throttle, there will be a screw adjustment that allows you to set the minimum closure on the throttle blade. As you adjust that screw, you change the resting position of the throttle blade. If the screw is extended more, then the throttle will be more open. If the screw is retracted more, the throttle will be more closed. If you didn't have an idle air bypass valve so that you didn't have any idle control on the car, using that throttle stop allows you to raise or lower the idle. Now, when you change the throttle blade position, you're also going to change the output of the throttle position sensor. That's this sensor, which is on top of the throttle. There's also quite a lot of old wives' tales about this sensor. Guys will tell you you have to get it to exactly 0.99 volts for best throttle response and so on. That's not really true either. What matters is that generally that throttle position sensor be under a volt and over 0.9 volts. Now, even that's not entirely true. When the car is keyed on, it takes a minimum throttle position reading and sets a value in there. Even if your throttle position sensor ends up a little bit above 1 volt, the car can still view that as a closed throttle. But if you get too far away from that 0.9 to 1 volt range, either too low or too high, you'll get a code set on the car, and the car may not actually recognize that it's in a closed throttle state. My usual target is 0.92, 0.94, something like that. Another thing that you should be aware of is that as that sensor heats up, the voltage output will increase slightly. So if you were to say set it at 0.95 volts, stone cold on a 70-degree day, let's say, then you started the car, took it out for a drive, got it good and hot under the hood so that the temperature of that sensor has increased substantially, probably 100 plus degrees, you'll see that the voltage output will have changed. So instead of being, say, 0.95 where you set it cold, it might be 0.98 or 0.99. So you need to be aware that it can increase. And that's why I suggest, in order to keep it under 1 volt, you'd like it to be under 1 volt under all conditions, not just cold conditions. It is not anywhere near as sensitive as guys would have you believe. So if it's 0.85 or it's 1.02, those values are probably going to work too. So you got these three physical things. You got the idle air bypass valve, you got the throttle position sensor, and you've got your throttle stop. How do you set this stuff up so that the car stops surging and so that it works? Well, the first thing you have to understand is how the control actually works. Number one, if you disconnect the idle air bypass valve wiring from the computer, it no longer has any control over idle. In that case, your idle is going to be managed entirely by the throttle stop. It has no ability to adjust idle for it being cold or hot, after startup, for your air conditioner turn on, or anything. It will run entirely based off that throttle position. And of course, the reason you use an idle control is to try and stabilize the idle under all of these kind of circumstances. When the AC turns on, you want the car to idle up a little bit so that it doesn't stall. When you declutch it and slam on the brakes to come to a traffic light, you want that idle to settle smoothly rather than just drop out where it might stall. The more radical your combo is, the bigger your cam, the more airflow the engine has, the more likely you're going to have idle stability problems. And that can include things like stalling if you were to disable the idle control system completely. How does the computer manage the position of that idle control valve? The engine management system uses a control type known as a PID controller. You may have heard these terms before. What a PID control is an adjustment that combines three separate types of adjustment in order to try and achieve a stabilized outcome. So the computer has a number of set values programmed into it, not the least of which is a target idle speed. There are also modifiers to the target idle speed, such as an engine coolant temperature modifier. That's why your car idles higher when it's cold and then gradually approaches a lower idle as it warms up. It has startup idle adders. So right after you start the car for a brief period of time, it's going to idle it up. Regardless of what adjustments it makes to the base target idle speed, it always has a target idle speed in mind. The default warmed up target idle for one of these cars is 672 RPM. So if you've got a factory computer with a warmed up car, that's going to be your target idle. Now, there is an engine coolant temperature modifier. The engine coolant temperature modifier doesn't go to 0 until you're past 160 degrees Fahrenheit. So if you put a really cold thermostat in the car, or your thermostat is in a failed open position and the car never warms up, you're always going to have an increased idle target. So the way the control works is this. As the car runs, the engine management system has a direct sample of what the current engine RPM is. When the car is in a closed loop idle mode, it takes the sampled instantaneous idle value and it compares it with the target idle value. If the actual idle is higher than the target, it's going to try and close the idle air bypass valve a little bit in order to achieve the target. If the actual idle speed is lower than the target, it's going to try and open the idle air bypass valve a little bit in order to try and achieve the target. Now, there are 3 separate ways that it makes that adjustment. The first is called the proportional adjustment. So this is a straight up proportionate adjustment where if the sampled value is a little bit higher than the target value, it makes a little adjustment. If it's a lot higher than the target value, it makes a big adjustment. The proportional value makes adjustments that are in proportion to the amount of difference between the target idle and the sampled idle, the actual idle. But there's more to it. The PID control has an integral term. And what this term does is it watches how much error there is over time. It gradually adjusts itself while the PID control is active in order to attain a more perfect adjustment. And what tends to happen when you use the P and I terms is your value, your idle speed, instead of just sort of oscillating back and forth around a target, begins to approach the target. It also uses a derivative term. The derivative term looks at the rate of change in the error between the target idle and the measured idle, and it provides an additional damping effect. So you can think of the proportionate part being the main adjustment and the integral and derivative parts being dampers to that adjustment. And the end result is that it uses an iterative convergence technique so that the idle overshoots and then undershoots by less, overshoots by less again, and then gradually approaches the target idle speed. Now, of course, your engine's never truly in a steady state and it's a pulse system. So you are always going to see little ups and downs on the idle speed. If you look at it with a data acquisition tool or any kind of a sensitive tack like the one on this timing light here, you're going to see that the idle doesn't stay stone cold steady, say at 672 exactly. It's going to be up and down a little bit. But what we really want to avoid is where it fluctuates wildly. So it's 100 RPM too high and then 100 RPM too low and it never settles down. Now, all of that may seem a little bit technical, but it's important that you understand how the control works if you're actually going to get it to work for you. One of the things that I see guys talking about is disconnecting your battery to do a base idle reset. Let me tell you something, this does nothing. These cars don't have a long-term memory of the idle control. In fact, that PID control resets every time the car enters closed loop idle. So when you go off idle, PID idle control stops. Then when you come back to it, PID idle control starts again, and it starts from pre-programmed settings that are in the computer, which you don't have any access to. That means disconnecting the battery is not going to erase any, bad learning or whatever. It just doesn't learn this kind of stuff. So you can forget wasting your time with that. That's not going to help you. So in practical terms, what can you actually do to try and get your idle under control? Well, step number one is it's very helpful if you know what your target hot idle speed is. Like I said, if it's a stalker, it'll be 672. If it's a cammed car and it's been programmed, lots of guys will change that target idle to 750, 800, 825, 850, something like that. It would be helpful if you knew what that value actually was. If you don't, you can take a guess. Your cammed car is probably going to need at least 750, if not more, in order to idle cleanly, just because a bigger cam doesn't want to run that well at low idle speeds. So after the timing is set, the first thing you should do is disconnect the idle air bypass valve. That will shut off all computer managed idle control, and then adjust the throttle stop so that you get the car to an idle speed which is just below what your target idle speed is. The car's a little bit cold right now, and in the interest of being a good runner, I set my target idle to 750. So you can actually see we're a little bit high, and that is we're at like 820 or so on here. And the reason for that is that it's got a little bit of a coolant temperature adder applied. None of that matters once we disconnect the idle air control valve. We'll lose complete idle control. So you see that? I pull that off so you can see my actual idle speed is right around 650 with the idle air bypass disconnected. The car is actually idling steady there. This is a stalker, so it should be okay there anyway. We could turn that up a little bit by adjusting the throttle stop. So the stock throttle, you can use a flat blade screwdriver. I'm going to go under here, I'm going to get on here, and I'm going to turn this up a little bit. And you can see we've raised our idle speed to around 700. So this is a little bit below our target of 750, which is programmed into this computer. Okay, now if I was to go ahead and plug the idle control back in, now you'll see it idle up on initial values, and then you should see that idle back down and approach the 750 RPM target as the car warms up. That's the PID control in action. So I pulled my computer up here. I'm at 180 degrees now, and my idle speed is hovering right around that 750. It's adjusted my idle speed control down to 33%, which means that valve is open a third. Having this idle speed duty cycle fairly low is a good idea because we want to rely less on the engine management system for our idle air. And we want there to be more headroom here for when it needs to up idle it, like when it's cold right after start with an AC kick and so on. In fact, you can see it continuing to drop down there, and the idle is quite stable right around 750. Also, we can look at our throttle position sensor. So our throttle position sensor is currently 0.8 volts. The minimum ratchet value is 0.7999 volts, and the car is running in a closed loop control mode. Now, ideally, we would want this to be a little higher. So we're going to go ahead and see if we can't turn this throttle position sensor in order to raise that up a little bit. You're going to say, Matthew, I don't have a computer to show me what my throttle position sensor value is. What can I do? Well, obviously the traditional wisdom is to use a multimeter and then back probe the wiring harness on the throttle position sensor. If you do have to do this, I suggest that you back probe the sensor side of the wiring, because at least that part is replaceable rather than the body side of the wiring. But what you're going to find is guys do this, they puncture the coating on the wiring, and then they get corrosion in there, and this causes all kinds of problems down the line. In fact, a possible problem that you have could be that your wiring has already been back probed one too many times or too far in the past and is corroded. So an easy solution is to build yourself an old school tool like this. All this is an adapter that's made out of both sides of the Ford throttle position wiring harness. This end is cut off of an old throttle position sensor. This end is cut off of a vehicle. And by the way, this can be any vehicle that uses this style of harness. So usually you can find a pickup in the junkyard that nobody is stripping this kind of parts off of and cut this off. Then you splice it together and you leave the green and black wires with a bare patch. This is the green wire, there's a bare patch there. This is the black wire, there's a bare patch there. This is the orange wire, and it is completely sealed up. Then with these bare patches, you can clip onto those with your multimeter and get a reading without having to damage your wiring harness. So to set this up, all we do is take our throttle position wiring, pull that apart, take our new adapter, plug one end of it into the throttle position sensor, like that, and plug the other end of it into the harness, like that. Now, there's a weather pack connection in here. Be sure that you don't double that up. Then once that's in there, you can take your multimeter, put on voltage if it needs an adjustment for that, volts DC, and then you can clip onto this connection. So we're going to clip our positive lead onto the green wire like that. We're going to clip our negative lead onto the black wire like that, and we're going to set that up in a way where they don't touch. That would be good. Turn the multimeter on. And then when we turn the key to run, we should see what our voltage is. 0.76. That's our resting voltage. Now, if we press the throttle in, you'll see that voltage increase. And in fact, it should increase to about 4.5, like that. And it should be smooth through there. So that's something you can check to make sure that your sensor is working right. Check that it advances smoothly. So now what we want to do is set this so that we can adjust the throttle position sensor. So we try to get this value up in the 0.9 range. So like I said, normally this is not an adjustable part, so we're going to have to take it off and slot these holes. If you have certain aftermarket throttles, sometimes this goes on a plate, and there are separate cap screws that you can use to adjust the plate and get your throttle position sensor adjusted that way without having to screw with the sensor. But let's just take this right off of here. Don't lose these screws. Now, a problem that sometimes guys have is when the sensor was put on, it was put on wrong. The little tangs in there have to be on the right side of the little spade on the throttle shaft. So in order to get that right, the way you do it is you rotate this counterclockwise when you put it on, put it in place, then once it's there, turn it clockwise until you can put the screws in. That way you'll have the tangs on the sensor on the correct side of the spade on the throttle shaft, and you'll be able to get a good setup. In order to get this right, I usually put little marks with a Sharpie on the side that I need to make adjustments to. You can see I've already made some adjustments on this. This throttle was completely out of range before, but I put a mark here and a mark here, and that means I need to file this way on this hole and this way on this hole in order to open them up so I can get that rotation the way we want it. I've seen guys do this with a drill. I have done it with a drill. Honestly, a little file is probably the most precise and best approach to sorting this out. And you'll see, if you look on the back, you'll see you can actually file right through. It's not the end of the world if you do, but you probably don't have to go that far most of the time. Okay, I've opened that up quite a bit more. We'll see if that's enough. You're better off to go in small steps and do this a couple times than you are to just go nuts and go too far. So now you can see I got a fair bit of adjustment there. What you want to do before you tighten this down after you slotted it, because you can get these slots off, is we should probably be going about this way. Let's just give it a brief sort of snug, a very light snug. So it still has a little movement there. Then let's cycle this throttle a couple times to make sure that we don't have it bound. Okay. Then we'll double check our wiring to make sure that we're not touching anything there. Everything looks fine. And we'll key it on and we'll see how far we got. So we're not quite where we want to be. So I'm going to take that off and I'm going to do it again here. And we'll keep doing that until we get a reading that we like. Another thing to watch out for is there's a little plastic grommet in here that can be missing. You can kind of see me work it up there. If that's missing, then you can get an air leak here. So that could be a part of your problem. I'm going to leave that in place. Obviously we need it there, but watch for this little grommet here to be missing. Also watch for an issue here where this part is a little bit proud compared to the screws, because if it is, when you tighten the throttle position sensor down, you can actually bend it, and that can cause that throttle position sensor to fail or give false readings. That's about 0.94. That's right in our target. Now you only need to snug this and then check that it doesn't move. Then after you've got it in there, cycle your throttle a few times and make sure it comes back to a value that you can live with. That looks pretty good. So that's rapidly approaching our target idle. The car seems nice and stable. Let me give it a snap. Comes right back, no oscillation. That's the way it should be. Okay, what if I went in here and I set this to 900? And then I went and set the max to 1150. Like that. And then I wrote this. Okay. Go back to our data log here. Now you see it's got that target for 900. It's opened up the idle speed duty cycle quite a bit, and it's at 900. Well, let's see what happens with the throttle snap. Even that is working pretty good. And let's try the opposite here. Set this back to 850, 824. I'm going to go in here and set these to 550. So remember, we have the throttle stop opened to the point where it should never be able to achieve 550. Let's see what happens there. So it's brought that duty cycle to the minimum possible. It's still idling at like 700. Let's try a throttle snap. Even that settled fairly well. I think you see I have a little bit more surging here. This stalker is not going to give you a wild surge, probably no matter what. But this is the kind of thing that happens when you have a big cam and you've got a stock target idle RPM, and then you just turn it up on the throttle stop. You end up with it sitting there trying to get to a lower value. And you can see it's way surgier here than it was before. I see values as low as like 660 and then back up to 750. So I'm getting as much as 100 RPM surge. This car isn't what you'd call running terrible, but this is the kind of thing that happens when you have a big cam, you turn the throttle stop up, but you don't adjust the target idle in your engine management system. It sits there and tries to achieve a target idle, which it can never achieve, and then it surges. Those are your steps to success. Set your timing, that's number one. Disconnect your idle air control valve, and then adjust your throttle stop so that your actual idle is just below your target idle. Your target idle 672 if it's stock. If it's been programmed, ask whoever programmed it what they set your target idle to. Then adjust your throttle position sensor so that it's between 0.9 and 1 volt. It's not critical that it be exactly there, but that's your target. If you have to, slot the throttle position sensor carefully. Also, when you're in there, double check that that plastic grommet is on the throttle to make sure that you don't have an air leak. Once that's done, the car should idle steadily. Don't worry about any of these steps like disconnecting your battery or standing on your head or waving a dead chicken at it or whatever. None of those things are real. These are the steps that are required to get that idle control set correctly. And like I said, if it doesn't idle right here, you're going to need additional programming, or you might have additional problems with the car, like vacuum leaks, a bad oxygen sensor on one side, those kinds of things. YouTube's going to recommend a video that they think you should watch from my channel. I'll put Foxbody Mustang technical playlist up on the screen for you. I hope you enjoyed the video. I hope it helps you get your idle under control. We'll see you next time.